Alright, welcome to the last video of Module 3. This is Section 2, 6.-2. We're going to be talking about normal distribution. What I want you to do is, it's not a mistake. Normal distribution, you only have one page of notes. And what you see in front of you, you need to write down verbatim. Do not, especially with the numbers that you see, do not do anything differently on your paper than what you see. If you write something down wrong or put a number that's not supposed to be there, all your answers from here on out for this assignment and on your homeworks and on your test will be completely wrong. So you need to make sure you do exactly what you see here. So normal distribution, it is how numbers are spread based upon standard deviation. More specifically, it shows what percentage of raw data falls within a given range based on that standard deviation. I like to do it like this, the way I talk about it. Everybody's buttered toast before. You want some toast, so you go to your bread box, you get out your favorite bread, and then you go to the refrigerator and you get your butter out. And what do? You take your butter knife and you throw this big glob of butter right smack into the middle of your bread. That is what you do. And then you take the knife and you slowly cut it from the middle of the bread, and you try to spread it from the middle to the crust, and you do it to the other directions and all the way around. But still, no matter how hard you try, the bulk of your butter is still in the middle of your bread. You're just going to have this big glob of butter in the middle, and the only way that you can avoid that is if you have spray butter. And who wants spray butter? Because that stuff's nasty. If you want butter, you get real butter. And so that's kind of what happens here. I've taken all the raw data and I throw it on a piece of bread and I try to spread it out. But no matter how hard I try to spread it, I can't make it completely even, and all of my numbers will always fall in the middle. That's kind of the way I want you to look at this. And so this is what this chart is showing. It's, if I took all my data and threw it right in the middle, like you see me circling right now, and just threw it right here, and then I try to spread it out, notice that the bulk of my data is still in the middle. Well, everything else, which is like right here would be my crust of my bread, well, very few numbers go to the crust because very little of your butter ever makes it to the crust. All right, so that's kind of the concept here, is how we're spreading it out. But it's also being, not only is it being spread out, but it's being spread out based upon standard deviation. So just to kind of cover this up, notice how this says, just so you can understand what's being said here, I'm just going to give you the numbers and then we're going to see some problems. This first one, where I'm circling, this is 34%. This is 13.5%. This one is 2.35. And this last one, notice that on your paper you don't have an arrow, but you need to draw an arrow going to the right, and it says 0.15%. All right, so that's 34, 13.5, 2.35, and 0.15%, and that's drawing to the right. Now look, on the left side is a mirror image, 34, 13.5, 2.35, and then my arrow going to the left with 0.15%. Up at the top, you have two arrows. You have where it starts in the middle, this side is 50%, and the left side is 50%. Okay. Now, down at the bottom, you should see where the boxes connect. Well, the first connection is what we call 68%. The second connection is 95%. And the last one is 99.7%. All right, finally, notice that I did not write anything in these boxes. I don't want you to. Right now, do not write anything in these boxes because you need those boxes blank right now. But what I do want you to do is starting in the middle. Above the middle box, it's the symbol for mean, followed by +1 standard deviation. That's a SD. If my S's look like 5s, sorry about that. So this is +1 SD. Then it goes +2 SD, +3 SD. That means +1 standard deviation, +2 standard deviation, +3 standard deviation. And the opposite side is mirrored, but instead of pluses, it's now minus. So -1 standard deviation, -2 standard deviation, and -3 standard deviation. All right, so this chart right here is all you need to be able to answer your homework questions, okay, and your test questions concerning these types of problems. Now, as this only works if you have done and copied everything that you see on your notes exactly as you see it. Now, the other thing I'm going to tell you is on your final exam, this little graph that I've given you right here, this is what we call a bell curve. This little graph, I would draw on your 4x6 note card because you're not going to really have this. This graph is in your notes, but is not nearly as detailed as what I have given you. So make sure that you have this on your 4x6 note card come the final exam. All right, so now that we've covered this, and hopefully by now you've paused the video and you've copied this down exactly like I wanted, let's just go right straight to the problem and explain this out. It's a whole lot easier once you see it. All right, so I've opened up the homework, and this is literally your first question. Okay, it says a normal distribution has a mean of 15 and a standard deviation of 4. Use the 68, 95, 99.7 rule to find the percentage of values in distributing between 15 and 19. Well, what's the 68, 95, 99.7 rule? Well, that's normal distribution. Normal distribution is also known as the 68, 95, and 99.7 rule. Okay, and what that's telling you to do is when it says use that rule, it's telling you to use this chart. All right, so let's go ahead and start with this. And really all we need to worry about is this very first sentence. It tells me that I have a normal distribution with a mean of 15 and a standard deviation of 4. Well, let's start easy. Let's talk about the mean. All right, so let's go to our chart and let's use a different color. Let's use orange. That sound good? Well, you see where our mean symbol is? Well, in the box that's just below it, this is where a pencil would be very useful. In that box, write 15. All right, now I apologize for my handwriting on the computer. It's not the best. Now, so I have 15 right smack in the middle where the mean is because it has a mean of 15. Then it tells me I have a standard deviation of 4. Now look at what this is. This says +1 standard deviation. Well, that's really saying +1 times 4. Well, what's 1 times 4? 4. So this is saying 15 plus 4 gives me 19. Now I'm getting ready to make this a whole lot easier. What really is happening here, and I'm not going to go into all the mathematics, but guess what? You are now counting by 4s. It goes 15, 19. Well, what's 4 more of that? It's going to be 23. What's 4 more after that? 27. So I counted by 4s, and notice that I counted in a positive direction. So 15 plus 4, 15 plus 4 plus 4 again, 15 plus 4 plus 4 plus 4. Or I get 15, 19, 23, 27. Okay? Because all I'm doing is counting by 4s. Now I'm going to count by 4s the opposite direction now. Where this is 15, this is now going to be 11. The next one is going to be 7. Sorry, that went a little overboard. And the last one is going to be 3. And my handwriting is really bad. All right, so I've just completed my graph. I have 3, 7, 11, 15, 19, 23. Now let's actually read the problem. What is it asking me for? It says what percentage is between 15 and 19? All right, so I'm going to switch to a different color. There we go. And I'm going to look for 15. Well, here's 15 and here's 19. So I need to look for the percentages. Well, all I have to do is look up top. What percentages are between 15 and 19? Well, the only one that's between those two happens to be this guy, 34. So between 15 and 19 is 34. So that's it, 34%. Let's find out if we're right. Done. Let's go to another question. Matter of fact, let's hit similar question. All right. Well, now it's giving me a different number. So I'm going to read this problem, and while I'm doing that, I'm going to clear out my board over here. It says that a normal distribution has a mean of 8 and a standard deviation of 2. use that rule, 6895, to determine blah, blah, blah. Well, look, it says I have a mean of 8, so I'm going to use my red this time. I have a mean of 8, so 8 goes in the middle. And it says I have a standard deviation of 2, which means I'm going to be counting by 2. So this box is going to be 10. This is going to be 12. This is going to be 14. Now we'll count the other way. This would be 6. Whoa, that's really messed up. This would be 6. This is going to be 4. And this is going to be 2. All right, so then it tells me what's between 8 and 10. Well, here's my 8, here's my 10. The only percentage that's between 8 and 10 happens to be 34 again. So that just happens to be a coincidence. It's 34. All right, next question. Let's do something else. While I read this, I'm going to come over here and clear some things out. It says that I have assume that a normal distribution has a data has a mean of 13 and a standard deviation of 2. All right, I'm not even going to read the rest of it. It says I have a mean of 13. Well, the mean is going to go in the middle. It says I'm counting by 2, a standard deviation of 2. So this is going to be 15. My handwriting's getting bad again. This is going to be 17. This is going to be 19. This is coming over here will be 11. This will be 9. And this will be 7. Wow, that really went off. My mouse must be dying. All right, so now look at the question. It says what percentage percentage of values lie below 11? Well, here's 11, and I'm going to just change my color a little bit. Let's change it to, we'll change it to blue. So 11 is right here. So I am looking for all the numbers that are less than 11. So I'm going everything that's in that direction. So I need to find all the percentages that are in this direction that are below 11. Well, the first number I happen to see is 13.5. The next number I happen to see is 2.35. And the last number I see is 0.15. Well, since I know that all of those percentages are on this direction because it's below, I'm just going to simply add them all up. So I'm going to do it with my calculator. 13.5 plus 2.35 plus 0.15, and I get 16%. Let's find out if we're right. 16%. Good. All right, so let's do another question. All right, so I'm going to read this one. I'm going to clear this out. Oops. Clear this stuff out while I read it. It says that I have a normal distribution of data that is got a mean of 25, and I have a standard deviation of 3. Well, I have a mean of 25, so 25 goes in the middle. I have a standard deviation of 3, so I'm going to be counting by 3. So this is going to be 28. Then it's going to be 31 and 34. Okay. The next one is going to be going the opposite direction. I'm going to go 22. Then I'm going to go 19. And then lastly 16. All right, let's read the problem. It says what percentage is above 28? Well, let's just change my color again just to, we'll do green this time. 28 is here. All right, and it says values that are above 28, so it's 28 in everything that goes in that direction. All right, so what numbers are going to be included? Well, 13.5, the 2.35, and the 0.15. Well, that's happens to be the exact same numbers we got last time, and when we added it up, we should have got 16. Let's find out if we're right. That's it. Okay, now look. Everything is a rinse and repeat type of situation. All right, let's just do one more. I mean, shoot, I've already about done half your questions already. They're just that quick. Let's just do this last. I'm gonna do. Yeah, let's do one more. I want you to figure this out, some of it out on your own, because it's not that hard. Let's see. Let me do something here. I'm gonna find a different problem. Yeah, let's do this last one. Okay, this one seems mighty wordy. All right. It says 4,000 students take a college entrance exam. The scores on the exam have an approximate normal distribution with a mean of 66. You see that little funky looking backwards Y thing or whatever? Don't worry about it. All you need to understand is that the mean is 66. And then it says a standard deviation. Well, this is like in the last video. It's the letter O with the curly with the Superman curly Q hair. Well, that means sigma. Well, this was what we talked about in the last video. We didn't learn to calculate sigma, but look, no big deal. We just need to know that the standard deviation is 12. So we know we have a mean of 66. Well, that's easy enough. So hopefully, my mouse is really dying now. We have a mean of 66. Woo, that's bad. Let's change that color out. Let's go back to red. That seems a little bit easier to read. Have a mean of 66, and I am counting by 12s. Well, 66 plus 12 gives me 78. Sorry for the... I need a better mouse now. It's 78. Then 78 plus 12. Well, that's going to give me 80. That's going to give me 90. The next one is going to give me 102. All right, now we're going to go back. 66 minus 12, that's going to give me 54. Then I'm going to get 42. And then lastly, I should get 30. All right, now look at the problems. It says estimate the percentage scoring 66 or less. All right, well, there's a couple of ways we can do this. So let's do it the way I've been kind of showing you. So we are going to use this. Here's my 66 right here, and I want less. So it's everything in this direction. So what I'm going to do is I'm going to find all that. Well, there's 34 that's in there. There's the 13.5. There's a 2.35, and there is the 0.15. Well, since I have all four of these, I'm going to add them up. And when I do on my handy dandy calculator, you get 50. Now, check this out. Did we really need to add them all up? Not really, because look at the very top. Notice how the mean, I was coming from the mean and I was looking at less. Well, look, I've already given that 50 to you already at the top. Since I knew it was at the mean and it was less than the mean, well, it's 50%. And so that little number was already there for you, okay? So that's cool. Now, what if, let's look at the next one. It says I want 90 or more. So just to have a different color, orange. All right, so 90 or more. Well, 90 or more is everything that I'm highlighting now, that 2.35 and the 0.15. I add that together and I get 2.5. Done. Now, what if, I'm going to change this one problem, and I think this is actually where I'm going to end it. But what if I wanted, instead of what the problem gave you, what if I wanted between 54 and 78? I want the percentages between 54 and 78. Well, all I have to do is check this out. Let's go to green. That looks good. Well, here's 54. Here's 78. And it's the numbers between them. So it's this right here. It's this section right here. Well, one, we should automatically know that these two are what we're going to use. But look, 34 plus 34, guess what that's equal to? Hey, it's the 68 down at the bottom. So when you have these two numbers, like notice how the one standard deviation, the -1 and the +1, when you have them connect, just like we've kind of happened here, well, that's 68%. If I ask you between 42 and 90, well, notice how those two connect at 95%. All right, well, since we're on a good go, and it's no big deal, let's just do one last one. All right, I will tell you this. Look, you see these? They're very wordy. There's a lot of words in it. But look, all you need to know is this. This guy has a mean of 35 and a standard deviation of 5. That's all you need to know. Plug that information into your graph and then solve for the answer. All right. Same situation, seems wordy, but look, has a mean of 40 and a standard deviation of 80. Plug it in, answer the question. Yeah, let's just finish this. All right. I didn't realize I was going to do so many problems with you, but they're just so quick and easy, it doesn't take any time whatsoever. All right, and goof. No. All right, well, anyway, looks like my system just crashed on me anyway, so I guess I'm not going to do another problem with you. So that's it. That's all normal distribution is. If you've got this chart and you can basically just fill in the information that you have, you're done. There's nothing else to worry about. These problems shouldn't take you long. The hardest thing that most people have with normal distribution is the fact that it's too easy. More people get normal distribution wrong because they are overthinking. All you have to do is exactly like I showed you. Put the mean exactly in the middle and then count by whatever the standard deviation is. And that's it.